Welcome back to another Marcus Maths video. Today we're going to be looking at the intermediate value theorem, and this will be our final video going over the quizzes in Unit 1 of AP Calculus BC, limits and continuity. The next video tomorrow we'll be going over the Unit 1 test. That's going to be a review with probably around 20 questions, so expect a little bit of a longer video tomorrow. Today we're just going to look at this one concept pretty much. Let's go ahead and get started. Make sure to like and subscribe if you haven't already as we go through this whole AP Calculus BC course in Khan Academy. Let's get started with question number 1. So I've mentioned that this unit is pretty much all about, well, this topic is all about intermediate value theorem. It's important to understand what it is. It's very self-explanatory, actually. It basically says that if a value is in between two y values in an interval, and we have a continuous function. We talked about continuity last time in the last video, so make sure to visit that if you haven't. So if g is a continuous function over this interval, and if the y values, let's say the y values are 3 for -2 and 5 for +4, if g is a continuous function, we must have a y value of 4 somewhere in between that interval. Makes sense. If we go from 3 to 5, we have to go up at some point if this is a continuous line, meaning we're not going to have any breaks in the function. So that's basically how intermediate value theorem works. How this question works is that we're going to select the interval, the specific intervals that must contain a solution. That's how intermediate theory value works. There must be if this is y value is 3, this y value is 5, there must be an x value that the y value is equal to 4 in that interval. Alright, so let's take a look how we would solve a question like this. We're going to test each of these intervals, so we'll start with answer choice A. We have the x value of -2 and the x value of 0, and we're going to see if -1 is in between the two y values that correspond to those x values. The y value for the x value of -2 is equal to 1, and the y value for x is equal to 0 is -2. And we know that -1 is in between 1 and -2. So if the function is going to decrease from +1 down to -2, there has to be an x value where the y value is equal to -1 in order for that to happen if g is continuous, which is a required constraint here. So answer choice A is correct. Let's look at answer choice B. From 0 to 2. From 0 to 2, we have -2 for the y value. For 0, and then +3 as the y value for 2. We know that once again, -1 is indeed between -2 and 3. So if the function is going to increase from -2 to 3, there has to be a value that is equal to -1 at some point. Let me show this in a graph. So let's say we have 0, -2, and then we have 2, 3 over here. And then our y value is equal to -1, so let's draw that line. Somewhere, in order for a straight line, it can go like this, it can go like this, but in order for it to reach, if it's a function, in order for it to reach our 2, 3, it has to cross this at some point, no matter what we do. If the line, if it is to remain a function, and if it is to remain continuous, it must cross that line in some point. And that is the basis of the intermediate value theorem. So we know that answer choice B is also going to be correct. Now let's test the last one from 2 to 4. The y value for 2 is 3. Y value for 4 is -5. And we know that to go from +3 to -5, we have to pass -1 at some point. -1 is indeed between those two values. So that means all three of these must contain a solution where g of x is equal to -1. Let's move on to this next question. Remember, we need to prove that our value is between the y values for the two x values for the interval, and that the function is continuous. Those are the two parts of the justification that we need to have. And this is the kind of response that we'd expect to see in an FRQ. Okay, so we have the function h of x is equal to x times sine of x, and we're trying to write a formal justification to for the fact that the equation y equals 1, or h of x equals 1, has a solution from between 0 and 2. First of all, we need to say that our function is continuous, and this statement does indeed fulfill that. Yep, her justification is also right here. And then let's see, we get the values. H of 0 is equal to 0, h of 2 is equal to 1.82, approximately 1.82. And yeah, 1 is indeed between these two values. So we have both of our constraints filled by this paragraph right here. And then, since both of the constraints are filled, we can then apply the theorem. Yes, this justification is fully complete. Okay, very similar question here to number 1. We're looking which intervals must contain a solution to y is equal to 3 between this interval. Let's test each of these. So first, from -1 to 2, we are going from 0 to 4. Is 3 in between 0 and 4? And is our function continuous? That is the case for both of these. Yep, since it's continuous and the value of 3 is in between those two y values. Answer choice A is correct. Now let's check answer choice B. Answer choice B, yep, we have the y value of 4 and the y value of 9. Since 3 is not in between these two values, the function, even though it can have a solution y is equal to 3, for example, if we had 2, 4, and then 4, 9, all the way up here, our function, it could still go down to this line, y equals 3. It could look like this, right? However, we cannot definitively prove that. It must, well, it is not a must. Because we can also say, for example, just go straight up. And in that case, we never have a solution where y is equal to 3 in between that interval. And since it's not must, we cannot use the, well, since it is not between the two values 4 and 9, 3 is not between 4 and 9, we cannot use intermediate value theorem to prove that the function must contain a solution to y is equal to 3. And that last one here, from 4 to 5, is 3 in between 9 and 15? Once again, not the case. 3 is not in between those two values. So only A is the correct answer with this one. Okay, another justification. Remember, continuous, and we need to prove that our value that we're looking for is in between the two y values corresponding to the x values in the interval that we are given. Okay, let's take a look. Gives selected values of the continuous function. Alright. Yeah, even though it says it, in our justification, we still need to mention that the function is continuous. Notice, Christine's justification, we do prove that 80 is between the two values. It is indeed between 140, so 80 must be in between those two values. But Kristen never mentions that f is continuous. We have to establish that in order to use the intermediate value theorem. Doesn't matter if they mention it in the question, we have to mention it ourselves in order to provide a complete justification. Answer choice C is correct here. And then last one, which of the following is guaranteed by the intermediate value theorem? We're just going to see what y value is in between the two y values that we're given here. We're given 0 and 6. We already know that g is a continuous function, so we do not have to mention that, unless we were, of course, having to provide a justification where we would have to restate that g is continuous. And we have the two y values, 0 and 6. We need to find the value, a y value that is in between 0 and 6 for the given interval x equals -3 to x is equal to +3. -2 is not in between 0 and 6, so we can rule out A, and to answer choice C, now we have two of them where our y value is equal to 5, or in this case it would be our g value, c would be x here. Oh, no, it would just be our y value here. C just represents an x value, my bad. Okay, so 5, it is legitimate since 5 is in between 0 and 6. For at least one c between -3 and +3, or between 0 and 6. Remember, the c represents the x value, so it needs to be in between the interval. So we're going to have at least one y value equal to 5 for when x is in between the interval. And the interval that we are given, it's not 0 and 6. Those are the two y values that we're given. We are given the two x values of -3 and +3. That means answer choice B is correct. So intermediate theorem, we need to prove these two constraints, and then we can make conclusions based off of it. I hope that you enjoyed this video. I'll see you guys again tomorrow for the whole unit test of Unit 1, Limits and Continuity. Make sure to subscribe if you haven't already, and goodbye.